I think being a first gen, of course, it has disadvantages. It's like playing on hard mode on the get go, like,
Yeah, yep, that's a great way of putting it. And are there any everyday examples of plasma?
lightning is a form of plasma. There's actually a cool experiment don't try this at home, kids. I believe, yeah, if you heat up a grape and in a microwave it, you will actually see plasma. You can look it up on YouTube, but yes, that's like a former experiment to see plasma in person.
Welcome to the Quantum and Beyond podcast, where I make quantum physics personal to you. On today's episode, we are continuing our series on life in science and beyond, where I'm joined by the amazing Destiny Howell. Her pronouns are she, her, hers, and she is a Ph.D. student in space physics at UT San Antonio. She's currently working on NASA's Tracers mission through the Southwest Research Institute, where she's contributing to rocket payload development for a mission launching soon. That is super amazing. And we're definitely going to talk about that during our conversation today. Destiny, welcome to the Quantum and Beyond podcast.
Thank you, Latoya. Thank you so much for having me. I'm so excited.
Yeah, absolutely. Absolutely. Let's first just start with your origin story,
Yeah, that's a great question. So let's go back to when I was a little girl. I always loved science. My mom always take me to the library, or even Barnes and Noble too. And I read all types of science books, crossing from marine biology to earth science as well. But I came across this book. It's called The Universe, and I found it in Barnes and Noble. I forgot the author's name, but that book honestly touched me as a little girl, because when I flipped through the pages, I'm like, oh my God, that's what the sun looks like, nebula, stars, other planets too. And, when I was little, I was like, oh, I want to do this. I want to get into this type of field. So I knew, I love science. I did good in science classes from middle school to high school. I did fine in math as well. I took physics because I was like, okay, the closest thing I could study astronomy was physics, what's available around me. So I was like, okay, let me do physics in high school. I did fine. I did good. So I was like, okay, let me continue into college. So I went to Hunter College, right? And my first year, I was able to jump into research really early on through mentorship, fellowship through the Flatiron Institute at the Center for Computational Astrophysics. And for 2 years, I studied gravitational waves, binary black holes. And I just had a supportive, mentors there, So I did 2 years at the Flatiron. Then the year after that, I went to UT Austin for the RAU, or the research for the summer undergrad. And I studied brown dwarfs. So I was looking at the cloud structure atmosphere from different brown dwarfs. I'm doing observational work. It was my first time going to the McDonald Observatory. And it was my first time seeing the galaxy. And I'm like, oh my God. I was like, wow, I'm just amazed by that. And my last summer, before going to grad school, I did my last RAU at Stony Brook. And that's when I was getting my hands-on instrumentation project. So that's mostly my origin of how I got into physics.
Yeah, for sure. Thank you for sharing that. How would you describe how you felt when you first started learning about different galaxies and planets and stars? Take us back to when you were that little girl.
Yeah, that's a great question. I mean, it definitely did spark something, I will say for sure, compared to when I read other science books, I told my mom and I guess circle of people who's around me that I want to be a scientist. I want to wear a white lab coat in a laboratory. That's what I thought I was a little girl, I was so determined. And I did the best I can to get more touch of that physics side, Did something that was supplemental to physics. I've done boot camps. For example, I did a coding boot camp during my middle school. In high school, I was able to take college courses that was through a program. It's called Double Discovery Center. So it helps low-income students in New York City to get access to lectures from Columbia lecturers to teach about all types of fields. So I got a chance to touch on biology, nuclear science too, even. I took advantage of that. I also took calculus and physics. So, as a little girl, I was really stubborn, determined, hey, I want to do this. So I did the best I can to find what's available. And of course, my mom have supported me. she's my rock. Like she didn't go to school. She couldn't, but she knew that I needed like extra support and like extracurricular so I could be prepared. So yeah,
Mhm.
I was really driven to get these opportunities at a young age because of my mom.
And actually, speaking of that, so it sounds like you were a first generation
Yes.
student. Yeah. How do you think that informed your journey, not only into physics, but gaining all of the skills and the experiences to really fulfill that dream of becoming a physicist?
Yeah, so I guess what's interesting being a first gen, either like people came from like people who they went to college, were educated and stuff, and like my mentors, for example, their parents were like professors, so they kind of have that, I guess, guidance or fluence. But I did not have that, obviously. So I had to basically, learn from what my mom was doing, which was like just learning how to scout for resources, learn how to ask for help, just be more open-minded to things, because yeah, I'm basically, I'm the first in my family, not just even to college, like high school too and middle school. My mom didn't even go to middle school, her education was cut short in third grade.
Right.
So at that point, like I learned how to be more self-reliant on myself. Because, my mom, she did the best
Right.
she can, but I knew that, that was our disadvantage. So yeah, I learned how to reach out for support. I learned how to know where to get support. I knew where to be resourceful when I need to, where to ask the right people, the right timing, the right place as well. And I think I learned how to, I guess, have an emotional intelligence that's come with it too, So you learn how to ask for things. You know how to read the room, the body language, who is an ally, who's not an ally. It is a learning on the go. That's what I learned. I appreciate it right now where I'm at PhD. It's a whole different ball game. So like I'm still learning on the spot. So it definitely made me like a resourceful person as a first gen college student. Um, Definitely very stubborn too. Like I had to be stubborn. I had to be. And I think because I was open to things. I reached out to different opportunities that's like space physics. Like I was doing nuclear science on the side. I was doing business on the side, science communications and like other outside things of physics. So I think being a first gen, of course it has disadvantages. It's like playing on hard mode on the get go. Like,
Yeah. Yep. That's a great way of putting it.
yeah, being a freshman made me as a go-getter, honestly, hardworking, persistent, open-minded too, resourceful, and all of those things are so helpful right now where I'm at right now as a PhD student.
Yeah, no, it's true. It's very, very true. And can you talk about the importance of being at the right place at the right time? Yeah, go for it.
Yes. I have a great example for this. During my first year in the PhD program, I went to my very first conference. I went to my first NSBP NSHP joint conference. Um, it was my reason to go was to see back the people who look like me, and I just wanted to escape from Texas. It's okay to take a breather where you're at. It's healthy, be human. So I needed that breather to get out of Texas. I'm from New York City. Like it's not like New
Hmm.
York. And like San Jose was good enough for me. They got buses and railroads. I'm like, perfect. And skyscrapers too, which I needed. Yeah, so when I was there, beginning wise, it was fine. Went to a lot of talks. Got a chance to talk to some students, people like above me, people undergrads too, and like faculty members, professionals too as well, networking sessions too, and I had a presentation to do my poster talk on the last day to present, right? Oh my goodness. The beginning was rough. I'm proving my speaking skills when it comes to presenting my research because sometimes, you get a little bit nervous, a little bit imposter syndrome bickering behind your ears, whatever, saying like, oh, you can't do this, blah, blah, blah. So I was having a little bit rough in the moment in the mornings and I was like, oh my goodness, let's just get it over with, Destiny. Let's just get it over with. You know what I mean? So I presented my current research and we had judges there, right? So we had judges come by and like they will score the highest person with the best presentation, whatever, and like give them a award and cash prize money, whatever, right? In the beginning I had one guy who was great. He loved my research. He was like, oh, this is amazing. He's like, I hope to see you again for the next joint conference. I'm like, yeah, I hope to be back too, But then I had two other professional came by. One studied specifically on plasma and one studied like astrophysics, right? So, Latoya, it was so difficult. They was asking me so hard questions, you know?
Mm-hmm.
And, I was my first year. I was just starting in with my project, I was still getting the gist of things, I'm still learning, but they was asking me hard questions. And like, I was telling myself, I was like, oh my God, I'm like, am I meant to do this? Am I built for this? Honestly, cause like the questions, like, and I did the best I can to give them the response. And I mean, I don't know, their responses wasn't like they didn't seem satisfied in my eyes. And then I had this plasma physicist came up to my poster. He was like the last professional who came up to my poster. Then everybody else was students. And I wasn't sure he was a judge too, but I was like, okay, maybe a judge. And he said it's important information at the end, by the way, which helped me a lot. Cause if I knew in the beginning, oh my God, I would be so nervous. So he was like, oh, your title of your research. I also do plasma. I'm actually interested in what you do. Please tell me about it. Tell me details about it. So I gave him the spiel. I did. Of course, like, he asked me hard questions. But what was different between him and the other two judges was that the question, it wasn't seem like, it was like a criteria checklist. But him, it seemed like he was actually excited and intrigued like what I was doing, the way how his reaction was towards me and the way he was following up with my responses. They were hard. Don't get me wrong, they were hard, but it was a different interaction, different feeling, different vibe I got. And I don't know, back in my head, I was answering and he said I was doing a good job, but in my head I was like, I don't think I'm doing a good job. But at the end of it, he was like, what you're doing is amazing work. We need your work at Princeton. Are you available this summer for Princeton? And I was like, I said yes. I didn't know.
Didn't check the calendar. I was like, yep, I will make it happen.
I was like, yes. I was like, yes, I am free for this summer. Please, yes. And he's like, okay, amazing. Let's exchange contact information. Let's stay in touch because I know people at PPL would love to work with you because your work is so valuable what they're trying to solve right now. And I was like, yes, we would love to do that. So we exchanged information. As I was putting his name and his email down, I told him like, oh, what's your title? So I won't get confused, like, when I look you up. And he's like, oh, I'm a director of this laboratory. And I was like, I forgot what laboratory, but he told me, I was like, glad you told me that. At the end of my poster talk, because I'll be so nervous the whole time I was talking to a director of a laboratory. So yeah, no. And, actually me and him actually stay in touch. And it's going well. So actually this Thursday, he paired me up with like the head person of who's in charge of the PPL laboratory, who's overseeing like the whole, like the facility of it. His name is Dr. Eric Gilson, like the head person of the Princeton PPL laboratory. Got a chance to meet with him on Thursday. We had a good talk and he was like, yes, we need your research. Your research is what we're looking for actually for our two facilities. And it went really amazing. And I don't know, I was so nervous. I'm like, oh my goodness. I did Google of him. I'm like, oh my God, he's a head person of PPL. He must be so strict and like cutthroat and everything. But no, he's the sweetest guy ever. It was like a conversation, and he was just so curious too, like about more about me, who I am, what I do. And, I just told him like, oh yeah, like, cause this, this joint program I'm in, which is UT San Antonio and joint with the Southwest Research Institute. I get opportunity to do NASA mission, which is like building a sounding rocket, which I'm doing. And he was like shocked. And I'm like, yeah, I'm a contractor for there too. So, I literally get the hands-on experience of like, mission designs, like actually calibrating stuff. And like, it's so cool, and he was so impressed. And he would just tell me how like, the Southwest is so prestigious. We're always looking for people to hire from there too. If you know what he was trying to hint something on that. And he's like, yeah, no, that's really amazing work I do. And yeah, no, we just got to know more of each other. That's what I learned about as I did more research about they experiment labs. And of course, I asked my PI his perspective on it, like what question I should ask. You know what I mean?
Right.
So like, yeah.
That's collaboration.
Exactly. That's the definition of collaboration work. Exactly. And yeah, I told him like, hey, because I'm a contractor at the Southwest, I have like access to like the top NASA missions, MMS, Themis, Tracers, and eventually Ochre, which we're launching, the ending of this year. And, I could give you that perspective, as a space physicist landscape, how we study plasma, you know what I mean? like special magnetic reconnection they do at their laboratory. And I was telling him his, and I said, I did research and, I learned from my advisor too, like what you guys' current problem is. And I said, I think what we doing could actually help you guys that. And I said, for exchange, like I would love to get a hands-on diagnostic tools what you guys use. Because I think to become a better like experimentalist or data analysis, like it's always a point to learn like what type of experiment and tool you guys are using to study that type of phenomenon. That's why I told him that, and he's like, "Oh yes, we would love to have you that all that stuff." So after that, everything went really well. He asked about the logistics, the timeline, and it seems everything checked off. And like we talk about funding opportunities, so it looks like it's gonna happen.
That's so exciting. That's awesome. So for the audience, for perspective, so there were a couple things that were dropped. So one is NSBP and NSHP.
Yeah.
So NSBP, National Society of Black Physicists. This is an organization that is dedicated to supporting Black physicists at every stage of the education journey, from high school all the way up through postdoc to being a physicist. So high school, college, Ph.D. and or master's, postdoc, and career physicists, whether in industry or academia. And the same mission, but applying to Hispanics. So this is the National Society of Hispanic Students, same type of mission. And so they have collaborated together these last couple of years to host a conference. And so for science conferences, this is the time where physicists gather from all over the world. They converge onto a city, and we're at a convention center, and it's an opportunity to share what it is we're doing. And we, meaning usually undergrad, sometimes high school, all the way up to physicists in academia and in industry. So this is everything from actual science talks, presentations with the slideshow, as well as poster sessions. And so the next thread is poster sessions. So a poster session, everyone is in a room. We have these placards or boards, and these boards have images. And so think of a slide deck, but that slide deck is actually all pasted in order on the board. And it's a summary of the research that the scientist has been doing, usually the past year, maybe past couple of years. And it's a quick and dirty way of having lots of conversations, usually short periods of time. You get to, and what can happen is you get to have collaborations that can spark from it, because there are people who have like interests and they have a need, and then they talk to a physics student or a physicist, and they can figure out like, this sounds like we should really work together because what you're doing is really interesting and it's something that we need at our lab. And then that sparks the collaboration that could, last for, a year, 6 months, couple years, etc. So this is like one of the ways that scientists really work together. It's very kind of informal. It's very amorphous, but this is part of the professional development that we all go through to be scientists. Yeah.
You said it perfectly. Yep.
Thank you. Yeah. So let's actually get into your research. Let's actually start from the beginning. So for you, what is plasma?
Yes, the simple definition I would say for plasma is the fourth state of matter. It's basically an ionized gas. It's electrically charged ionized gas, and which have mixture of electrons and positive ions, and is found all over the universe, like the stars, the sun, interstellar space, etc. And it responds to magnetic fields, and it appears everywhere, like from the Earth auroras, lightnings, the magnetic connection, etc. So that's the simple definition of what is plasma. Yeah.
Awesome. And are there any everyday examples of plasma, or is it just like out in space that it typically happens?
Like I said, lightning is a form of plasma.
Okay.
Auroras, which is like, in our lower atmosphere, like, which is form of plasma. There's actually a cool experiment. Don't try this at home, kids. Let the school, like, teachers do this or professors. But like, if you heat up a grape in a microwave it, like, you will actually see plasma. You can look it up on YouTube, but yes, that's like a former experiment to see plasma in person. But yeah.
Oh, that's really cool. Okay. Awesome. And so now that we know what plasma is, what it looks like, what's the research that you do?
Yes. So I'm actually doing 2 in 1, but they all connect with each other, right? Mm-hmm. So one is like data analysis side, and there's one in like instrumentation buildings that. So let me talk about the first one I'm doing. So I am studying magnetic reconnection, which is a fundamental plasma process where you have magnetic field lines connect and break, which create energy and convert it into energy basically, right? So what I'm studying is like the variability of it. So I'm looking at the changes of like temporally and spatially throughout like our Earth magnetosphere, particularly at the magnetopause, because in that area, magnetic connection is so active over there.
Yeah, where is the magnetic pause? I don't think of that. I've never actually heard of before.
Yes. So if you have a diagram, right, it's basically you have Earth. This is
Hmm.
Earth. And like around Earth is a magnetosphere, right?
Hmm.
And like, I believe, yeah, where Earth is facing, where the sun is at, like that's where the magnetopause is at. Because that's where
Mm.
the interaction happens from the solar flare to our magnetosphere. Yeah. And that's where the
Okay,
yeah. So,
gotcha. Okay.
yeah. Okay, that's good. And to study that, we are using spacecrafts from MMS, NASA spacecraft from MMS and Themis as conjunction points to see, again, to see where it's at. And we are hoping to see, like, from looking at two different perspectives,
Hmm.
that how magnetic connection works. If it's like a on and off, like on and off, or like it happens simultaneously in that magnetopause area. You know what I mean? So that's what we do. And hopefully once I'm done with that first phase, which I'm still doing because a lot of data set points, but I'm almost done. Basically I'm doing a catalog of that. And after that, Tracers, which launched last summer, July 2025, I will actually supplement their data because once we launch it, it will be in the same orbital trajectory path where Trace will be at. And that'll be a great conjunction points data set to compare, like, again, with a magnetic connection at that particular area. So that'll be done in the second phase of the Themis and MMS mission I'm doing. And that data analysis part would be in the, like, between my third year to my fourth year. So yeah. So that's my first research in the, like, nutshell, cut up, like, first phase and the second phase. And then my second project is the sounding rocket. Like, my team and I are like building and like doing all that stuff, right? So my job basically right now is that I'm the safety check quality engineer. So I make sure that it is working properly, the calibration part properly, right? So I go to the chamber and I am doing some form of checks of it. Like, for example, making sure it propels correctly, like make sure the instrument is not over the place, you know what I mean, once it's launched up, checking the shock environment, like how hard it shakes and like how well they input the instrument we need to take our data in. So that's like about it. And like right now, starting in March, I'll be creating some codes, you know what I mean? And she said how the code will help us just to like practice and like make sure that like the instrument's working, like the instrument itself onto the payload of the rocket is working properly. So yeah, that's like nutshell of it. So those are two projects I'm doing currently on. Yeah. And the Sounded Rocket is like it's from to this semester to the summer because we want to ship it
Hmm.
in July. So that's how long the duration of this process I'm doing. And then I'm right back to doing data analysis, but with those two new rockets. Yeah, data. So
Okay.
excited.
And when those rockets are launched, are they going to return? Are they just on a one-way ticket?
Yeah. So Tracers that launched last
Mhm.
summer, it will keep orbiting. It will keep orbiting. It will
Okay.
stay. Since I'm on doing, which is the sound and rocket calibration part, it's a sound and rocket, so it's not meant to stay up that long anyway. Yeah, so it'd be up there for a short period of time. I don't remember. Isn't our paper that we published? How long we're gonna stay? How long is gonna be in that orbital path till it like launch back down? You know.
Hmm.
But yeah, the Sonic rocket is not for a long period of time, because it's just a Sonic rocket. Trace is actually a satellite, so it's meant to stay up there for a good minute of time, like with MMS and Themis.
Okay.
Yeah.
Okay. And what is the research motivation? Like,
Mhm.
why are we studying it? And
Yeah,
then for the everyday person, why would they want to also learn about this?
that's a great question. So the first one, like our motivation, because plasma is one of the like the hardest subtopic field of physics. We still don't know much about it, honestly. I think like true papers has published about it like around like 1965, something like that. So it's still a pretty new
Wow.
phenomenon, honestly.
Yeah.
Yeah. So there's still a lot to learn about it, you know? And we still know not much about magnetic reconnect. Like we don't know why does, like what it does in variability, like why does, if it like shuts on and off, like why does it happen simultaneously? So like we don't know what's going on. So we hoping that with these satellites we could, learn from that in observational landscape, Of course, there are laboratories are trying to simulate that, of course, like the Princeton laboratory. But what's so hard about it is that since plasma is so I don't want to say finicky, so what we have, like what we're looking at is called the diffusion area, the diffusion region, right, which is so important, right? And when in the laboratory sense, right, like for example PPL, when they have a probe, right, to like study that, it actually mess up the stability of it, like it mess up the heating process and the confinement of plasma. So
Mhm.
because of that, it doesn't work on their research. So what we're hoping that we could look at it in the observational landscape, because basically our satellite is our probe, basically like figuratively speaking wise, and our magnetosphere is like our natural laboratory in that sense. So it won't
Mhm.
disrupt the process of it, you know what I mean? So that's the motivation of it, to like, of course, like the fusion devices that we have here on our laboratories, and of course just to learn more about it, because it's still a growing new field, believe it or not. Yeah, phenomena itself. Yeah.
Mhm.
And why people should know about it, because when we have like solar flares and stuff, like it like, and thank goodness we have the magnetosphere. Without it,
Yeah.
people.
Yes. Yeah, we would not be here.
Yeah.
We would be like Mars.
No, exactly. It protects us, right? And like it depends like how impactful is the solar flares too. Like it interrupts our satellites, interrupts our like even GPS phones, like Wi-Fi, you know what I mean? So, and these things are like part of our daily lives. The world will not function without Wi-Fi. We need our Wi-Fi in our phones. You know what I mean?
Mhm. Mhm.
So it's so important just to learn ways to like not just only like learn the fundamental of it in the physical sense, like again, like yeah, fundamental conceptually way, but also application wise, like we could even figure out more ways like how to have better advancement with our satellites for better protection, so it won't interrupt our day-to-day lives, like those sort of matters things. So that's why people who don't study what I do, like you should read more about it. You on your phone scrolling right now about it, so it's so important. Yeah.
Awesome. Yeah, great. Awesome. Thank you for that explanation, because I think, that there's a lot of physicists doing a lot of things. And I think it's really important to show that, yes, there's definitely physicists who are studying phenomena that may not feel like it's directly, directly helps other people, showing that the work that you do also does, not only is it really cool and really interesting, but it does also directly help,
Yeah.
to help people like just feel a little bit more connected to it.
Yes.
Now, you're a PhD student,
Mm-hmm.
and I'd love to talk about, what is it that fills your cup, whether it's inside or outside of physics, and even what your experience has been like. What was that transition from being a college student to now being a PhD student?
Yeah, I love those questions. So let me answer the first one, like what fills my cup? Because that's so important, you know what I mean?
Hmm.
Self-care, man. So for me, again, I'm from New York City, right? So growing up in that environment, there's no place like New York City. So so when I went to Texas, San Antonio specifically, I'm speaking wise, and I'm like, okay, it's nothing like New York City,
Yeah, it's
you know what
different.
I mean? Like it's so dry, everything's flat, like not a lot of people, like nothing going on. But and I was like, okay, I need stimulation. What I do is, and that's the purpose of PhD program. You learn more about yourself, like again, what your research is, and like more about yourself personally and professionally. So what I learned is that, like, yeah, I don't see myself staying in Texas at all. Once I'm done with my PhD, I'm going right back to the East Coast.
Hmm.
And how I fill my cup is actually going to these conferences. Honestly, that was the reason why I went to the NSBP joint conference, was because, like I said, just to escape, I need to see people that look like me. You know what I mean? Coming from New York City is so like we're diverse, people all over the world. You know what I mean? But comes to San Antonio, like it's a bit homogenous. You know what I mean? And on the conservative side, so like I had to like get out, just for my well being, and I'm glad I did. Even though it was like it's a conference, I was there to present my work, but like it was still like a breather I needed. So what I have been doing is that look for opportunity that's like outside of San Antonio, just to give me that again, I guess stimulation, and of course like some form of rejuvenation back again. Like I said, I felt rejuvenated when I saw people that look like me doing cool physics research, you know what I mean? And again, going to a environment like, yes, San Jose is not like New York City, but it got transportations, it got skyscrapers, it got diverse food, diverse culture going on there. So like I had a good time there, and it helped me a lot with my homesickness too, not gonna lie. And we could dive more into that later on. But like applying to like those outside opportunities programs has helped me a lot, honestly, to fuel my cup. And this too, like I'm trying to make it as actually like my main habit. I'm actually going back home for the summer. Cause like I miss my family and friends and like the people who
Yeah.
support me. Like I need to go back to where my roots is at. Cause without that, it's been really hard. Sometimes, as a PhD student, it's like it's hard. Like, what is the reason why you're doing this again? Sometimes you be
Yeah.
so like into your work as a student, and like you forget the purpose why you're here in the first place. So me going back home, it reinforced that like, oh, now I know why I'm here. You know what I mean? It gave me that. That's like the love, the support, that purpose again, why I'm here there. You know what I mean? So that's how I fill my cup, honestly. And of course, this too now, I think like ever since San Antonio is like a slow paced place, like there's nothing going on here. I guess this is a benefit. Like I've been napping more. Napping is so important. I feel like people, especially in America, I guess too, like we about like work, 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 which is fine. But like at the same time, we humans, so you need to like rest and take it easy and take a breather. So going to a slow pace where people just stay at home most of the time, like I learned how to like, I guess like nap more of myself. And like I forgot how it's just how it feels good just to nap again. Um it's just a
Yeah.
basic.
Sleep is underrated.
It is underrated, and people don't know how important it is actually to being your full potential capabilities. You need rest. Yeah, so I've been napping a storm, and it feels good. It feels good. I forgot that feeling, and nap is so important. Like when it comes to like a cognitive work or like physically, like all that stuff, emotionally wise, like if you don't have your nap, you won't be yourself. You won't be yourself. So that's what I want to appreciate. I'm napping more often, and I'm learning how to like, I guess, taking a breather, take a step slower, take your time, because like everybody's in a slow pace, so might as well.
Yeah,
So
absolutely.
that's how I fill my cup in. Sorry, what was your other question? I'm so sorry.
You're good. I did kind of ask two questions at the same time. The other was just what's different about being a PhD student compared to being a college student?
Okay, yeah. Yeah, it's definitely like your title. Definitely your title. And what I mean by that, like, you're not just only a student, you're also a researcher and possibly like a teaching assistant, whatever, if you do TA, whatever. And you actually your professor as well, at least my advisor, he actually seen me as his colleague level. So that's the interesting dynamic here, because undergrad, everyone who was mentoring me, I see them like someone to look up to, you know what I mean? Up there, authority, like the dynamic authority level is different, obviously, right? But I mean, yeah, still your PI is still above you, but you're in that phase of like in the professional sense, like phase, right? You know what I mean? So you're not, as you progress, you become a less more of a student, you're becoming more like actually like a professional, you know what I mean? Like a scientist, a researcher. And you basically like your PI is your collaborators, like he or she's working with you, like head to head, you know what I mean? Like it's not like a like somebody above you and like you work on it's not like that. I mean, of course, like they're your boss, like they have the funding and stuff, but like
Right.
you more as actually become like adult, you know what I mean? And like you actually
Hmm.
treat it more like uh as a, I wouldn't say employee, but like legit colleague actually, you working alongside with them. So that's an interesting dynamic I had transitioning from a student to a PhD student, because I still kind of have that mindset like, oh, he's my mentor, there's so much I want to look up to him, learn more from him, and etc. Like, take me under your wing. But like, that's not the dynamic no more. Of course they're there to support you, but it's not the same like from undergrad. Like, I don't know, but my undergrad, they were so supportive to the point, like, like I feel like it was a different type of support, for
Yeah.
sure. Like, they push you and all that stuff. But this one, like, you on your own. But he's right there, or she's right there to help you when you need the help. You know what I mean? So it's like a different dynamic itself of that. And I guess this too, like, I realized this too, like, people have taken me more seriously too as a PhD student, which is interesting. And as a contractor too, when people hear the word, I work as a contractor at the Southwest, it feels good, not gonna lie. It feels good that
Yeah.
I guess people do take you more seriously and see your credentials and stuff and, like, hear you out and, like, actually want to collab with you and do work with you.
Yeah.
Because yeah, so it's not random, but like it's related to like again, my title as a PhD student, right? When I post my title, my PhD title, hey, as a space physics student, PhD in my LinkedIn title, right? And I was just searching around, googling around of like game developers, whatever, because I'm also part of a project I'm doing, which is like a nuclear game idea I'm doing. We could talk more about that later on too.
Yes.
But yeah, no, I was just scrolling. I was on some people's pages and like, okay, like I'm done. The next day or so, I got an email from this game developer who's the lead game developer for Nintendo Pokemon, who said how like, oh my goodness, like you're a PhD student in space physics. That's so cool. I'd like to get to know you more and etc. And I was like, oh, I would like to get to know you more, you too. You legit a game developer, lead developer for Nintendo Pokemon. Like that's so cool too. So you know what I mean? Like you would not expect like how much doors has opened just because of the title itself. And I'm learning that on the way, especially like again the Nintendo thing opportunity now PPL. Because I swear I went to a lot of posters during my undergrad, but I didn't get that type of like opportunities. So, like this itself legit tells you like the title itself is so big, which I never knew, but and I'm going to take advantage of that. That's why I'm going to keep going to conferences, keep going to a workshop, put my name out there, because you just never know. You just never know. So being having that title itself, it will unlock a lot of opportunities, a lot of things that you would not expect.
No, it's absolutely true. So for perspective for people, when a person is enrolled as a PhD student for physics, they are usually either in two positions. They are either a TA or teaching assistant, and that's someone who writes papers for probably their mentor who's teaching classes as well, and maybe proctoring exams and things like that, grading exams, and offering office hours to students, undergraduate students. And then, so if they're not a TA, and they're getting paid for this too, by the way, it's part of their stipends for being a PhD student. If they're not a TA, then they're what's called an RA or a research assistant. And so that's when you're directly working with your mentor, advisor, et cetera. And basically whatever they need, they'll ask you to do it and you go and you do it. And you work a certain number of hours and that's what you're getting paid to do. And that will eventually be on top of the actual research you'll do, the actual original research that you'll do. So in Destiny's situation, she's in a unique position because she is a contractor. And so that means that she is paid by the contracting company. Is that correct? That's Southwest?
Yeah.
Yeah, right. And that's what she's talking about in terms of the title, both as a contractor, meaning she will have a different dynamic with her mentor because yes, her mentor and her PI or principal investigator is her boss, but not to the same degree as an RA or a TA. So you're even more so colleagues. And then on the outside world, like with posting on LinkedIn, absolutely. As soon as someone hears, whether it's you're a PhD student in physics, or even just studying, even an undergrad, if you're a physics student or you got your BS in physics or BA in physics, there's definitely a switch in how people perceive you. Because I've noticed that as well, after getting my BS in physics and even during the time I was in school. And it's true, it can lead to all sorts of really amazing opportunities because of that. So it's kind of like shouldn't be your primary reason to get a physics degree, but it definitely helps in terms of professional opportunities. Yeah. Cool. So this nuclear game, please share more because that sounds really cool.
Yes. So the nuclear game idea, right? Let's go back like when I graduated. Yeah, when I got my BA in physics, I went to college. For that summer, right? Yeah, I took actually I did a semester gap. So I had like a long time to like figure out like what I wanted to do once I like graduated from Hunter, right? So, I looked into these opportunities, all that stuff. So like once I was done with Hunter, I did a Johns Hopkins business program, and then after that I did study abroad to do like AI and cybersecurity. And then the last ending of my summer, that I did a nuclear innovation boot camp. So basically it's an international program where they have students, researchers, professionals all over the world to come in to create ventures ideas on nuclear landscape, right? And the first week is 2 weeks long. The first week is lecture based of nuclear concepts, energy market, like business concept too, etc. Right? And then the last week, that's when you come in, you pair up into teams and you guys create like an ideation phase of like what idea you want to do, etc. Blah blah blah, and then you create like a pitch deck. You present to the judge, and then you compete within each other, and the winners get great prizes. So my team and I won first place for our nuclear game idea, which is basically that we want to create like a mobile app game that simulate the nuclear power plant, right? And the purpose of that game is to teach people that nuclear has a great, we try to demystify how, nuclear, what is bad history, of course, but we trying to say like looking toward the future is that like it has great benefits. Like our game idea is to show people like, oh, it can help power up the city, which is so important. You know what I mean? And of course, there's other more like examples of that too, how nuclear is so, it can be really helpful for like sustaining like cities and like our world, etc. But that was our purpose of our game. And of course, the hope of our game is to, like I said, to inspire the youth that nuclear industry is a possible career opportunities or things to look into. And, we hope to get a demographic from like high school. Cause for me, yes, I have met students, they were learning what they want to do in high school, which is normal. You know what I mean? Well, me, like I had unique case, like I know since like elementary, like, oh yeah, I want to study physics, but you know what I mean? Not everybody have that opportunity or that chance, So we hope to create this game just to inspire the youth that like, hey, nuclear is a fun, cool science thing to learn about, and possibly a career like you want to do like in the workforce. You know what I mean? So that's the purpose of our game. And yeah, we came first place. And coming in first
Nice.
place, it
Yeah.
comes in like we won money, so $4,000. And we went to the congressional trip to Abu Dhabi. So we went to the conference there. Oh my God, I forgot the abbreviation of it. But it was a big conference. So it had like a lot of researchers, policymakers, scientists, professors, students from all over the globe actually to come in for this conference, this big conference, just to discuss about the nuclear, what's the next year looking like with nuclear, how it's going path forward with different countries wise. And it was an amazing opportunity, my first time going to a Middle Eastern country, you know what I mean? And like me and my team went together, learn about the culture, and like, of course, meeting so many cool people, It was a one-in-a-life opportunity, and I will never forget that. And honestly, that experience itself, and with the Nintendo guy too, who's like our informal mentor, like it just keep pushing me like, okay, like they want our idea to happen to reality. Like we have supporters, we do. So that's the nuclear game sense of it. And our next step is that we are currently, okay, so fingers for the Nintendo guy. He has found like volunteers, etc., who wants to help build the game. And our next step is to find like funding opportunities. So what he did was so nice that he helped me connect with this guy who was part of the DoD, the Department of Defense, but now he works at eSport. So hopefully, like with his past connection, like his experience, he could help us like funding opportunities in the DoD. You know what I mean? And like other things he may know of, and like the next path with our game moving forward. So like he has helped us so much, and I'm glad like there's people who actually believe and I see outside of our ideas. So it just keep pushing us, honestly. So that's the nuclear games, and we call it criticality too. By the way, our game, like our
It's a
team,
great
called
name.
yeah, criticality.
Yeah, that's super, super cool. And that's hopefully that gives people perspective of like one of the tricky things with trying to convince students that majoring in physics can lead to so many paths is the fact that it can lead to so many different paths.
Yes.
Right. But if you figure out kind of even just what direction you want to head in, even if you don't know what the destination is, there are so many opportunities along the way that you can pick up, whether it's game development or a science related game, whether it's traveling to, was it Alaska that you went to?
Yes.
Yeah. And we'll talk about that in a second. But like it was instrumentation.
Yes, it was. Yeah.
Yeah. Okay. Instrumentation related, and backtrack for instrumentation. What we mean by that is literally the equipment that scientists use to collect their measurements, whether if we're talking about satellites or rockets or observatories, or even for other fields, it could be something like what's the name of that? I think it's also called a sensor. I'll put it at the bottom. There are these special, I can't believe I forgot the name of it. For oceanography, there are also these tools. Are sensors that look very similar to a very small rocket, to sonars. That's it. You put them in the water and they sound out high pitched sounds. We can't hear them, but it sends out high pitched sounds, and the sound waves hit against the particles and then rebound back to the sonar. And then they collect that data to figure out, how much stuff is in the water, how much dirt, how much salt, what's the temperature, how fast is the water moving at different levels. So like that's an instrument. So there are people across the sciences who sometimes focus specifically on how do we build instruments so that we can take accurate measurements. Yeah. So, do you want to talk about Alaska?
Oh, yes, of course. Yeah, so I came across this opportunity. It was a summer school at Alaska, right, at Fairbanks University, right? And basically, it's about learning about the ionosphere, right? So, we have the atmosphere, and then there's the ionosphere, and then like the magnetosphere, and blah, 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 and all, So
And
that's
can you share what the ionosphere is?
yeah, so ionosphere is a layer that's above our upper is the Earth upper atmosphere, and it basically acts like an interference to space, right? So it's formed by like solar extreme X-ray radiation, ionized atmospheric gases, and yeah, it's like an ionized atmosphere that is, I guess, created by the solar radiation.
So as a way maybe to describe it, obviously we are very close. We are on the surface of Earth. So we have our atmosphere, and our atmosphere is, it's like 30% oxygen, mostly nitrogen, and some other trace atoms and chemicals and whatnot that's in our air. And that's how we human beings are able to survive here on this planet. So
Mhm.
that is a whole set of gases that allow us to live. That's a layer that surrounds our planet. There's another layer that's just above that also has 3 different types of atoms. But because it's further away from our planet, there's more like interaction between that section of our atmosphere and the sun, right? And so if you take a step back to middle school, where we learn about atoms and molecules, atoms have protons, neutrons, and electrons. Electrons, when they're hit by light from the sun, and light for us, we call that radiation, the electrons jiggle. And when they jiggle, they're releasing energy. And that energy is also radiation. So that layer we call the ionosphere, because when those electrons jiggle, some of them get ripped off, and it creates an imbalance in that atom. So some atoms tend to be a little bit more positive. Some tend to be a little bit more negative. But they have a certain number of electrons that are the same number of protons. But if an electron is ripped away, now that whole atom is excited because it's like, oh my God, where's the electron? And it gets really excited and also releases radiation.
Yes.
Right? So that layer, we call that the ionosphere.
Yes. And you said it perfectly. A dense plasma is composed of dense plasma with like a lot of electrically charged particles, like, yeah, electrons, positive ions, and some other composition to like, like other like molecules, whatever. But yes,
Yep.
you said it perfectly. Yeah.
Yeah.
So I was there at Fairbanks that summer for 2 weeks studying the ionosphere. And the purpose of it too was to it was actually an interesting summer school. It was like more of because you know how summer school, they have their own agenda, like what they want you to learn and stuff, right? For this one, it was interesting. It was actually more like, oh, what do you need assistance with based on the tools we have, which is HARP. What they have is HARP, and I could quickly Google what the acronym of HARP is, but basically HARP is their facility there at Fairbanks. Well, it's farther than Fairbanks. It's actually Gokona, which is like I think about 3 or 4 hours away, if I remember when we took that long drive. But yeah, so HARP, which is acronym for High Frequency Active Auroral Research Program, one of the top ionospheric research facility there in Alaska, Gokona, which analyzes the Earth ionosphere, right? And is managed by University of Alaska Fairbanks, right? So the purpose of the summer research was to I guess recruit students and like PIs or faculty or postdocs to help them aid their research that will use HARP to answer their questions, right? And I guess you could say that I'm in an interesting situation because the purpose why I applied to HARP, well, the summer school itself was because I just want to learn about ionosphere, you know? I was, a first year. So I just wanted to learn about space physics itself. So I thought it would be a great opportunity. And when I was applying, it asked for like your science question that you want to solve and stuff. So, read some quick papers, think of something that like I could do that is doable in the HARP facility. And at the same time, like it was a good question to solve too there. It was an interesting summer school. But yeah, the first week was like lecture based. Like, so everyone's on the same page. What is ionosphere? And like, again, they talked about like the purpose of HARP, the history, blah, blah, blah for the first week, etc. And then the last week, that's when we went to, in person at Gokona at HARP, to like use their instruments, to like solve out one of our questions, right? Basically, it was a great experience too, my first time in Alaska, my first time seeing auroras, so beautiful.
I bet.
And it was my first time too, like doing like I guess field work, because like so how it works is that like you need so what's so good about it, right? You could bring your own equipment or they have the equipment for you, right? I didn't have no equipment, but they had some there, right? So I used the equipment what they had to help me with my science question, right? So basically you had to set up the transmitter and the receiver to get the data and stuff, right? And like go to like the control room to see how the data looking like and just like convert it and like then you do more data analysis based on that, right? And it was a great experience, honestly. Like I never done field work, like actually setting up the equipment outside to make sure like it takes in like, so it sends out the data and receives it, etc. You know what I mean? Yeah, no, it was a great experience. Like I said, first year, too, I was the first year grad student there. People was impressed, like me doing this and stuff. Yeah, it was a great experience. It was a great experience to the point that even the program manager wants me back. She wants me back because like yeah, the research was it was good. It was a great research question. Like yeah, it was good. It was good, and they wanted me back. Honestly, they really enjoyed working with me and stuff. So yeah, definitely Fairbanks, Alaska University is such a good school, and they really great known for like space science research over there. So I definitely recommend people look into them if they want to do those type of things or just explore what's available for them. But like they really have top notch like research for space physics up there as well.
Awesome. Yeah, I'll definitely put that among many other programs that you mentioned throughout in the show notes.
Yes.
Cool. And so you've had so far so many different kinds of experiences from game development to a little bit more on the business side. You've had instrumentation, data analysis.
Mhm.
What do you want to do after you're done with your PhD?
Yeah, so I have like a lot. Okay, yeah, definitely compared from definitely compared from like when I was little, right? I just said to myself like, "Oh, I just want to be a scientist," which is still true to this day.
Yeah.
But I'm more open-minded now based on like the exposure I have now, from undergrad to now and like continuing forward to what life lead me to. Right? So, my first dream job or my dream career aspiration is become a scientist, like either work at NASA or some other research facility places like PPL, for example, too now, even at HARP too, now they know me and stuff and also not just only be a scientist alongside being a science policymaker too. I realized how we need to like teach like the broader public like how important science is, and especially in this political climate right now, like science being attacked, like that's honestly pushed me like, okay, like we need to protect science. We need to keep growing more scientists, honestly. We need to keep making advancement, you know what I mean? Like there's a part of me I want to do some form of science policy work as a scientist, you know what I mean? And it could be whether it be fellowships or like when I'm done being a scientist or like when I'm just, we see what life takes me. Yeah, I'd be open to that, honestly. And I've been doing opportunities, not exactly because I'm still looking for it. Believe it or not, it's interesting because when I had my first interview, we were trying to get into a science policy program. You kind of have to act like a politician, low key. Like you have to like talk
Mm.
like really fast, and like you need to have your points really like like to the point, like what you want to say within like 10 seconds, like to get their attention, which is like crazy. And I never had that interview ever. You know what I mean? And like it had what you said to be like natural autopilot too, and it's like, oh my god, I never had that training. So, but it was a good
Mhm.
exposure for me. So I know better when I reapply again to other science policy programs. But wow, it's a different feel when it comes to getting into, because when you apply for like research wise, like it's either you
Yeah.
talk about your capabilities, your technical skills, your social, your soft skills, your resume, rec letters, what you put down, why this research interested you, what can you bring to the table, how they could help you, etc. Like that, you know what I mean? And like, and the fit of like the teamwork, like dynamic. Science ball is a different whole game. They give you rapid fire question and they hope for you to like say a good right response at the right timing. So it's like an interesting thing ever. But hey, I'm glad I got that exposure because now I know better for when I reapply, you know what I mean? So that's my first dream, like my dream aspiration jobs, you know what I mean? My second one is to hopefully that the game, like the nuclear game, it, actually go viral and like, I actually become like a full-time CEO, you know what I mean? And like, yeah,
Would
keep
love
pushing
to
that
hear it.
game. And hopefully to expand it, instead of being a mobile game, we could expand it to PC game, Xbox, PlayStation, and hopefully we could bring some initiatives too,
Mhm.
like NASA like version, or like the DOE version, whatever, like they sponsorship and some collaboration work to create their games as well, just to recruit more students, recruit people into more science, like those type of things, you know what I mean? It's still open, like it's still open out there, you know what I mean? We're still in the starting phase of the ideation of it. But I'm excited where it could go to, you know what I mean? So hopefully become a CEO, good money of it.
Yeah, exactly, exactly.
And the last one, which oh my goodness, this one is like a dream. I would love to do this one as well. Open the first space and art museum in Harlem in New York City. We do need that. We do
Yes,
need that. You know what I mean?
yes,
Especially in the because Harlem is like, well, I hope it still is, you know what I mean? Because gentrify and all that stuff. But like,
yeah,
there's still heavy black culture there, you know what I mean? And we need to like inspire more, like black kids, like, you know what I mean? We need more of us in this field. So I think having something that's like there physically and something beautiful to see, that like science is not scary, especially space physics, space science too, you
yeah.
know what I mean? So like having that bridge, like in a community that's like, it needs that a lot, you know what I mean? To those axes of things. So I would love to have a space art science museum in Harlem and like be the co-founder of it and like operate and run it and like have like shows, scientists come in, artists come in, do their demonstration, have programs or like scholarships from there too, So like I would love to have that as well. But those are my three top like career aspirations. And I think I will like when I told people this, they were like, Destiny, like I see you doing all those things. They're
Mhm.
like, you unstoppable, you all over the place, girl. Like like you always see every single thing. Like you so amazing. They said I won't be shy. Like you achieve all those three career dream jobs. And I'm like, okay, we will see. But I'm glad people have faith in me. You know what I
Mhm.
mean? And I'm still young, in my second year, still my first second year, my semester, like, yeah. So like, yeah, so it's gonna happen. It's gonna happen one way or another. It's gonna happen one way or another. So
Yes, yes, I hear all of that and co-sign what everyone else has said as well, especially knowing you.
thank you.
Yeah. So one last question.
Oh wow. Okay.
Um, and it's not science related. I'm actually thinking of this on the fly. What is the last movie you've seen?
Mm.
The last TV show you've seen?
Mm.
And what was the last painting you created?
Mm. I love those questions. So one is movie, show, and painting I've created, right?
Yep.
Okay.
Yep.
Okay. Oh my goodness. This may expose like how busy I am.
Well, you are a PhD student. That's what makes this fun.
Yeah, I mean, I think the most recent movie I saw was actually last year during Thanksgiving. Me and my friend did a girls trip to Nashville, which was so great. I needed that break too. Like I said, like that was one of my how I fill my cup in. So me and her went to see Zootopia. She wanted to see it, and I was
Nice.
like, okay, we could see it. And it was a cute movie. It was a cute movie, I enjoyed it. It was like a good bonding moment too. It was kind of giving like Thanksgiving vibes too, 'cause Thanksgiving's like family together, whatever, whatever. And yeah, and like Zootopia is kind of like everybody, no matter what they look like, we all could like love each other, like respect each other, be in the same and coexist like So I definitely need that message right now. And what's
Yeah.
going on right now. Yeah, it was a cute movie. So, and again, it took me away of like physics and like science and hard. So like I said, I just needed like outside of things, you know what I mean? So that was good seeing that. TV show wise, so yeah, I went to my friend house sleepover when I was back in New York City, and we watching, it was like a sci-fi slash history um Netflix show.
Mhm.
I forgot what it's called, but basically, like, I forgot, it was the name basically when John F. Kennedy was assassin. And it was
Mm.
cool because basically the guy time traveled back in time trying to like prevent that. You know what I mean?
I think I heard
You
of
think you heard of it,
I know what
right?
you're talking about.
Yeah.
I'll pop it up. Well, I'll go
Yeah.
and find it and pop it up. I
Yeah.
know what you're talking about.
Yeah, and it was good, you know what I mean? Like it was just well, it was intensive obviously because it was back in the day, you know what I mean? And of course, like back in the day was like, yeah, it's very, but like, I like the concept of the idea, like traveling back in time, which is cool. Like one about top sci-fi, like ever think of, you know what I mean? And a little bit of history too, sprinkling too, you know what I mean? Like about John F. Kennedy, whatever, and like what led to his death and et cetera, which was so interesting. And like, I think they did a good job. I didn't finish it because that's when I was leaving back
Yeah.
to Texas, and I don't have Netflix. But
Right.
hopefully when I come back for the summer, like I finished that whole marathon with my friends, whatever, and then like yeah, it was good. It got me on my toes, honestly. So that was like the last TV show I watched. And for painting, that last thing I did paint it, which was so it's through this internship I'm doing right at my school, right? It's called the Advocacy Internship. It's through the department at UTSA called the Najim Center. Oh my goodness, I love them. They are they're the reason why, like, they also give me a reason why I'm here too, honestly, is, they might one of my safe haven people. But anyway, I'm doing an internship there, right? And part of the training, which was the second day, which was like how to manage stress. And we had like artist came in, like a career service person, then an artist, and like came in to teach us like how to manage your stress, blah, blah, blah. And we did like some form of art, you know what I mean? And so during that training session, out 3 hours, everybody was painting whatever they wanted painting, which shows paint of who you are. So
Mhm.
when she made that instruction, I was like, okay, I think I know what to paint. So basically I was painting like a selfie of me, which is a real selfie actually. It's a selfie of me of the reflection of the astronaut helmet reflect back at me. So it shows me like,
Mm.
there's me looking at myself of the, as an astronaut has a NASA logo on it. You know what I mean? And I think that's a great representation, like who I am, like reflect who is Destiny with that like image of it myself. Yes, I want to do NASA work. Maybe up in space. I don't know about that. But, like definitely be up there studying the science up there. You know what I mean? So like that was the last thing I painted. I didn't finish it though, but I will finish some. But that was one of my paintings I did, the most recent ones.
That's awesome.
Mm-hmm.
Yeah, that's I would love to see that. That would make a good book cover.
Yes, yes. Don't worry. When I was drawing it and painting, I'm like, oh, this is coming out so good. Like I had a lot of
Mhm.
people complimenting me. So I was like, okay, my art skill's not so bad since like, high school and stuff. So like it's still on point. But yeah, like it's coming out really good. I'll show you when I'm done with it. Yeah.
Yeah,
Don't worry.
cool. Well, Destiny, thank you. This PhD student, soon to be doctor in a couple years, like 3 years, you
3
think?
years, yeah.
3
I got
years.
really lucky
Yeah,
with my PI. He wanted to be out. I want to be out too. So we hitting that 4-year mark. So yep, got
nice.
really lucky.
Yes. Thank you for joining all of us today at the Quantum and Beyond podcast. Also how, if nothing else, a first gen gonna have hustle. We're gonna do what we gotta do to get where we
Exactly.
need to go.
Facts. Period.
Right? And
Yep.
with that, we're gonna close out the show. Thank you so much and go be quantum, everyone.
Bye everyone. Thank you.